All right, good morning, everybody. Today, we are going to continue adding and subtracting rational expressions. I'm going to do approximately 3 problems for you, and we'll just see kind of how this goes. So the first example, we have denominators that are not the same. This is not the same as this. Now, this is y to the first power. This is y to the second. So it would probably be helpful to change this from second power to first power. So remember, I'm looking for two numbers that multiply to 4 but add to 4. And that would be 2 and 2. So I found that this factors into y minus 2, y plus 2, y plus 2, and I'm adding on a y minus 2 over a y plus 3. So all I've done so far is I took this trinomial, quadratic trinomial, and I broke it up into the linear factors. Usually they have stuff in common. This one does not. So there is nothing in common in the denominators. So the LCM, because there's nothing in common, it's just going to be y plus 2, y plus 2, y plus 3. So I'm going to make my fraction, and I'm going to change them to a common denominator, y plus 2, y plus 2. And what am I missing? I am missing the y plus 3. And sometimes it helps to go ahead and put a y plus 3 down on both. And so now, when you're trying to change denominators, you can't just change it. You can add a y plus 3 here, but whatever you add in the denominator, you must add it in the numerator. So in order to add a y plus 3 on here, I need to put that in the numerator. And because y minus 2 is already together, I put that in parentheses. Here, I already have a y plus 3, but I'm missing a y plus 2 and a y plus 2. So I'm going to add that on there. And this problem is going to be a lot of work. All right. Well, from there, I could combine this into one fraction. I may not have room for all this. So we'll go. I would say this is probably one of the harder problems that I've done before, but we're going to put all this on one numerator all over this. So I have y minus 2 times y plus 3 plus y minus 2, y plus 2, y plus 2. Makes it look nicer if I put a piece of paper underneath it. Y minus 2, y plus 2, y plus 2. All over y plus 2, y plus 2, y plus 3. All right. From here, I need to distribute this and distribute all 3 of those. That's going to be some work. I might do that on a separate piece of paper. So first, I need to take y minus 2 times y plus 3. If I distribute that, I get y squared, 3y, negative 2y. I think I could use the regular paper. So if I distribute this, I get y squared, 3y, minus 2y minus 6. This makes y squared plus y minus 6. And then if I take this times this is difference of two squares. I know it already makes y squared minus 4. So these two make y squared minus 4. These two together. And then I have to multiply that by y plus 2. Or I get the opportunity to. And then I distribute y squared times y. That's y cubed. 2y squared minus 4y minus 8. And then combine like terms. Remember, this is a plus. So I don't have to distribute a minus. If this was a minus, I would then change all the signs. Putting this in order, I have y cubed. 2y squared and 1y squared is 3y squared. Negative 4y and y is negative 3y. Negative 8, negative 6, negative 14. All over y plus 2. And instead of putting y plus 2, I'm going to be lazy and put, well, I'll leave it as y plus 2. I could have put it as y plus 2 squared. Now from here, you could try to factor, which I'm trying to think. Sometimes this factors, you would use factoring by grouping. I don't think it factors. So we're done. Okay. There is a chance somewhere in here that I added wrong, multiplied wrong, wrote down something wrong. That's one thing that makes these tricky. I feel pretty confident, but it's very easy to mess up on these. And then your restricted values, you'd say y cannot be negative 2, y cannot be negative 2, y cannot be negative 3. All right, so that was probably one of the harder ones. Here, I have 3a minus 6, I have a plus 2. Okay, it may be tempting at first glance to say nothing in common, but this one has a GCF of 3, which changes that to an a minus 2. So really, there still is nothing in common. So the LCM is going to be 3, a minus 2, and a plus 2. So I'm going to set up my fraction with 3, a minus 2, and a plus 2 on both. So what is this fraction needing? It has 3a minus 2. I want 3a minus 2a plus 2. It's missing an a plus 2. I also can't forget about those. So if I add an a plus 2 down here, I need to add it up there. Now going from a plus 2 to 3a minus 2a plus 2, what's missing? The 3a minus 2. Okay, from there I could combine this into one big fraction. I get 4 times a plus 2 minus 3a, a minus 2, all over 3, a minus 2, a plus 2. From here, I'm going to do some math. So I'm going to do 4a plus 8. I'm going to distribute the negative 3a. So that's negative 3a squared plus 6a. From there, putting this in order from largest to smallest for standard form, I'd get negative 3a squared. And then 4a and 6a make 10a. And then plus 8. Now let's see if this factors. One thing I taught you beginning of the course is if this is negative, you factor it out, which changes all the signs. And then ask yourself, are there two numbers that multiply to negative 24 but add to negative 10? And there's a very good chance that there isn't one. Negative 12 and 2. Wow, it does work. Negative 12 and 2. All right. Then you do a minus 12, a plus 2. And I know I'm working like backwards the other way, but most people don't work bottoms up. Most people work top to bottom, but using the space I have. So I get a minus 12 divided by a plus 2. You divide by the 3. Then remember, if this reduces, you reduce. So you get a minus 4. If it doesn't reduce, you slide. And then I also have that negative I can't forget about. So all of this made this. So now I have negative a minus 4, 3a plus 2, all over 3, a minus 2, a plus 2. Now, usually something would eliminate. Nothing eliminates. So in reality, I could have stopped at this step. And I'm kind of disappointed that nothing eliminates. But usually what happens is once you factor it, then you could eliminate more factors. But that's it. That's all we could do. Some people would pull the negative out to the front. It doesn't really matter. One more example. I need two numbers that multiply to 4, add to 4. That'd be 2 and 2. Two numbers that multiply, actually this is difference of 2 squares. That'd make n and n, 2 and 2, 1 plus, 1 minus. In the last video, we said that you keep the 1 for the LCM. So if there's an n plus 2's here and here, you keep the one with the most. So my LCM is going to be n plus 2, n plus 2, n minus 2. As my common denominator, my least common denominator. I need more paper. And then go ahead and write down what you had. You had an n minus 2, and you had an n minus 4. And I'll try to start writing a little nicer. So what's missing? N plus 2, n plus 2, missing n minus 2. So I add that here. What's missing here? Going from here to here, the n plus 2. Because there's 2 n plus 2's. From there, I could combine this into one fraction. Let's see, that's n minus 2, n minus 2, minus n plus 4, n plus 2, all over n plus 2, n plus 2, and minus 2. Distribute n squared minus 2n makes minus 4n plus 4. Here, I'm going to keep that as a negative and then distribute this and see what I get. N squared. No, I can't read my own writing. N squared plus 2n plus 4n makes 6n plus 8. I then distribute the negative. So that changes that to minus n squared minus 6n minus 8. N squared cancel. That's nice. 4n minus 6n is negative 2n. 4 minus 8 is negative 4. And then negative 2n minus 4, you can factor out a negative 2. You get n plus 2. So all of this made negative 2n plus 2. All over the denominator. And then finally, an example where something eliminates at the end. N plus 2's go away. And then that's my final answer. So I have negative 2 over n plus 2 and minus 2. And then my restricted values would be negative 2, negative 2, negative 2, and positive 2. So that was our skill for today. Some of these examples are a little intense. They do take quite a bit of work. Like I said, they're very easy to say mess up on. Probably I'll watch this later or look at my work and I might find a tiny little mistake somewhere. But I'm okay with that because it is very easy to make mistakes, especially on this kind of thing. But I hope that you at least kind of understand that you're supposed to need a common denominator before you add and subtract. And that's really, if that's what you understand, I think you'll be fine. Other than that, nice seeing you all and have a good day. Bye-bye.